beneath the deep sky where stars drift like the slow breath of the cosmos, there lingers a gentle question that stirs the quiet within us. Why is everything spinning? From tiny electrons turning around the seed of life, to vast galaxies folding like ribbons of light, all things move in perfect silence. Tonight, let this story carry you into a space between science and sleep, where knowledge softens like wind and the mind begins to drift. If that motion touches you, leave a soft, like a gentle subscribe. So, why is everything spinning, yet we feel so still? Beneath the quiet turning of our world, there is a secret so gentle and so constant that most of us never feel it. The Earth spins at more than 1,000 miles per hour, yet our bodies remain calm, our breath steady, our thoughts unshaken. That stillness is not an absence of motion, but the perfect harmony of moving with the Earth rather than against it. Albert Einstein once reflected that motion is relative, a reminder that we are not separate from the journey. We are inside it. The same illusion follows our orbit around the Sun, a silent race of 67,000 miles per hour. Yet not a ripple appears in the water we drink, or the thoughts we cradle before sleep. Neil deGrasse Tyson often says that Earth is not just a planet, but a cosmic vessel carrying us through space. And like passengers in a ship moving smoothly across a glassy ocean, we feel only calm. Smooth motion leaves no trace on the senses, and in that quiet smoothness, we mistake movement for stillness. Our entire solar system is also on the move, drifting around the center of the Milky Way at nearly 500,000 miles per hour. Yet the heartbeat remains unchanged. The lungs rise and fall without a tremor. This serenity comes from inertia, a principle Isaac Newton once described as the universe's soft insistence that objects continue in their state unless disturbed. We do not feel the spinning because nothing interrupts it. Nothing jars us into awareness. Like a train gliding at perfect speed, only the sudden change, not the motion itself, is what we sense. And so, the question deepens. Not only why we do not feel the movement, but why everything in the universe spins in the first place. Max Tegmark once noted that rotation is the fossil memory of creation, and in those words lies an ancient truth. When the universe was still young, just a cloud of gas and dust waiting to become something more, gravity began its slow pull, gathering particles inward. As that cloud collapsed, the law of angular momentum stepped in, gently but firmly, ensuring that, as the cloud shrank, it had to spin faster. The same way a figure skater spins faster with arms pulled in, the early universe spun itself into stars, planets, moons. Earth's rotation is therefore not an accident, but an inheritance. Every turning molecule, every orbiting electron, every swirling galaxy carries that first impulse, an echo of the moment the universe learned to dance. Carl Sagan wrote that we are a way for the cosmos to know itself. And perhaps this endless rotation is one of the ways it remembers what it once was. Even the Foucault pendulum, hanging in quiet museums, reveals the truth our senses hide. It swings in perfect stillness, while the floor beneath it slowly turns, hour after hour, proving that the earth is moving even when our bodies insist it is not. There is beauty in that. The kind of beauty that feels like a soft breath on the edge of sleep. What fascinates me, as both a scientist and a storyteller, is the way this cosmic motion mirrors the rhythms inside us. Our cells hum, our atoms spin, our hearts beat in cycles. Motion is not simply something the universe does. It is something it teaches. From the steady turn of the earth, I am reminded daily that life thrives not in sudden bursts, but in gentle continuity. And the lesson hidden within this quiet cosmic spin, at least for me, is that stillness is often an illusion. We think we are standing still, yet we are carried through space on a world in motion. We believe our lives are unmoving, yet every thought, every breath, every moment is another turn in our personal orbit. Even the key word that defines this entire mystery, universe spin, feels less like a scientific term and more like a soft pulse, a reminder that the cosmos is always moving. And so are we. The more I reflect on it, the more I find comfort in this hidden motion, a sense that even when life feels paused, we are still carried forward by forces older than memory. It teaches patience, humility, and the quiet courage to trust the journey. So tonight, as you listen, breathing softly beneath a sky that turns without pause, remember that the stillness you feel is simply the universe moving too smoothly to disturb you. And in that perfect glide, perhaps there is a kind of peace. After all, if everything spins, and we spin with it, then every moment is part of a greater motion. Every thought a quiet orbit. Every breath a soft turning of a world that never truly stands still. In the quiet expanse of early space, when everything was still nothing and yet already becoming something, one question rises gently, like a ripple on dark water. Who or what first set the universe spinning? Scientists have searched this mystery for decades, tracing faint signatures left behind in the cosmic microwave background, those ghostly echoes of the first light. Within that delicate radiation pattern lies an unsettling alignment, a strange tilt in the temperature ripples that cosmologists call the axis of evil, a name whispered half in jest and half in awe. Some see it as evidence that the universe itself may carry a global rotation, a subtle drift imprinted across billions of light years, as if the cosmos once turned gently like a sleeping giant drawing its first breath. As the physicist George Smoot once said, "When you look at the CMB, you are looking at the face of the infant universe. And in that ancient face there may be a hint of twist, a faint memory of early motion. To imagine how such a rotation could begin is to step into the Planck era, that unreachable moment when time was still learning how to flow, when quantum fields rose and fell like restless tides. Nothing then was still. Even emptiness jittered with fluctuations, tiny variations in energy appearing and fading in less than a whisper. Stephen Hawking once remarked, "At the quantum level, the universe is never truly at rest." And perhaps it was this restlessness that seeded the first spin, During cosmic inflation, space expanded faster than light, stretching those quantum jitters into vast structures, threads that would later form galaxies. If any of those fluctuations carried even the slightest rotational component, inflation would have amplified it, turning microscopic swirls into cosmic eddies. Small curls in space-time that became the first whispers of angular momentum. Physicist Alan Guth often described inflation as a magnifying glass for the microscopic, transforming quantum noise into the architecture of everything. In that architecture, we find the seeds of galactic spin, the reason why galaxies today turn like vast spirals of starlight, each one carrying a rhythm older than its own birth. It is striking that nearly every galaxy rotates, not randomly but with orderly structure, as though following instructions written long before matter formed. That smoothness has led some scientists to believe that angular momentum is not an accident, but a relic, a fossil from the earliest moment of existence. And yet the mystery deepens. Even elementary particles carry spin, a quantum property that is not literal turning but something deeper, an intrinsic twist in their mathematical nature. Richard Feynman once said, "If you think you understand quantum spin, you don't understand quantum spin," hinting that this internal rotation lies at the core of reality, shaping chemistry, magnetism, and the structure of matter itself. To me, this layered spinning across scales feels like the universe clearing its throat, establishing a rhythm it has kept ever since. From quarks to superclusters, the same principle holds. Angular momentum conserved, carried forward, never lost. It suggests something both humbling and beautiful. That motion is not a later development, but an inheritance. When I reflect on this, I'm reminded of Kip Thorne's observation. The fabric of the universe is made of geometry and motion intertwined. Perhaps the universe did not need a hand to set it spinning. Perhaps motion is part of its very identity. A quiet pulse that began the moment existence itself opened its eyes. Some will ask the natural question: could the universe have rotated globally like a single colossal body, turning through the void? The evidence is ambiguous. Subtle alignments in quasar polarization, large-scale patterns in galaxy rotation directions, and of course the axis of evil. But none of these are absolute proof. Only soft hints, delicate traces. The kind you find when you follow a river back to its spring and see only dew on grass. In truth, the question may matter less than what it reveals. That we live in a universe where motion is fundamental, where stillness is the illusion, and where every spinning atom in our bodies participates in that ancient rhythm. The more I learn, the more I feel that understanding cosmic rotation is not just a scientific pursuit, but a philosophical one. It reminds us that beginnings are rarely static, that creation itself unfolds in movement, that even chaos has currents. If I were to extract a lesson from this cosmic dance, it would be this: motion is the universe choosing to become, not merely to exist. And perhaps that is true for us as well. We are our most alive, not when we stand still, but when we turn gently toward curiosity, toward wonder, toward the questions that keep us awake beneath a quiet sky. As this reflection settles, one question remains, suspended like a soft lantern in the dark. If the universe was born turning, what ancient motion are we still carrying within us tonight? In the quiet turning of our world, there is a secret so gentle yet so powerful that life itself leans upon it. The simple act of rotation, the steady spinning of Earth that we rarely feel. Yet without it, nothing we know could survive. If the Earth ever stopped, the rhythm of day and night would shatter. One hemisphere locked in endless sunlight, the other swallowed by eternal night. Oceans would boil on one side, while the other froze into a world of glass. The line between them, a violent frontier of storms. It is a haunting thought, that something as soft and invisible as rotation holds back such chaos. As Carl Sagan once whispered, we are shaped by the cosmic dance of light and shadow. And that dance begins with the Earth's quiet turn. From this rotation rises a delicate choreography of winds and currents, the great atmospheric rivers that weave warmth across continents. Without the Coriolis effect, the breath of the planet would collapse into stillness. Storms would not spiral. Jet streams would not flow. The climate itself would lose its pulse. Earth's spin stirs the oceans too, guiding the Gulf Stream across the Atlantic, carrying warmth that shapes seasons and civilizations. Neil deGrasse Tyson once said, "The rotation of Earth is the soft engine behind the weather we take for granted." And when one listens closely, it feels true. Deep beneath us, molten iron turns like a dark ocean of fire. And in that motion, Earth's magnetic shield is born. It is a shield that bends solar winds, protects our atmosphere, and allows life to hold its breath without fear. If Earth ceased to rotate, the dynamo within would quiet. The magnetic field would thin, and like Mars, our sky could be stripped away grain by the relentless sun. The thought is humbling, a reminder that the balance of life depends not on strength, but on motion. Biology itself listens to rotation. Each creature carries a clock within, tuned to the steady 24-hour turning of our world. Circadian rhythms hold our sleep, our hormones, our energy, all synchronized to a planet moving through darkness and dawn. Without that rhythm, the body's internal harmony would falter, cells losing their sense of when to heal, when to wake, when to rest. As chronobiologist Till Roneberg observed, our biology is written by the turning of Earth. And in those words, there is a tenderness that science sometimes forgets. Even the lengthening of our days tells a quiet story. For billions of years, the moon has been pulling at Earth like a companion tugging gently on a sleeve. This tidal pull slows our spin by a breath each century, stretching the day, sending the moon drifting farther into the velvet dark. It is a reminder that celestial bodies do not simply exist. They interact. They change each other. They evolve in a long, slow partnership, almost like old friends walking together through time. When we look to other worlds, the lesson becomes even clearer. The speed of a planet's rotation shapes its destiny. On Venus, the spin has nearly faded. A single rotation stretching across 243 Earth days. And in that slow turning, its atmosphere has become a furnace, a runaway greenhouse sealed beneath clouds of acid. Venus reminds us that a world too slow can be swallowed by its own heat. Mars tells the opposite tale. Its day nearly like ours, but its heart cooled too quickly. Its inner dynamo fading. Without a strong magnetic shield, the solar wind stripped its sky, dried its oceans, and left behind a desert of rust and silence. In the words of planetary scientist Bruce Jakosky, Mars is a lesson in what happens when a world loses its protection. In these tales of Earth, Venus, and Mars, we see a deeper truth forming. Rotation is not simply motion, it is identity. A world's spin determines its light, its storms, its sky. It shapes whether oceans flow, whether atmospheres survive, whether life takes its first breath. We often speak of gravity as the great architect of the cosmos. But in the soft shadow of that force, rotation is the sculptor, shaping worlds into homes. As I reflect on these ideas, I am struck by how fragile the balance truly is. Life depends not on grand explosions or cosmic violence, but on the gentle persistence of motion, a world turning steadily through morning and night. The lesson feels almost human, that sometimes survival means simply continuing to turn, even when we do not feel the movement. Angular momentum in space teaches us that nothing stays still. Not planets, not stars, not even the atoms that shape our thoughts. Every rotation carries memory. Every cycle holds a story. And when I think of Earth spinning softly beneath us, I cannot help but feel gratitude for a planet whose gentle turn makes life warm, breathable, possible. Perhaps that is the quiet truth hidden in the movement of worlds. Rotation is not simply a physical act. It is a form of care, a way the cosmos nurtures the fragile shapes that call it home. And as you listen to this story, drifting gently between thought and sleep, may you feel that motion, soft and ancient, carrying us all across the dark. In the quiet language of the universe, rotation is more than motion. It is a soft hand shaping the very flow of time, bending it, slowing it, curling it into delicate spirals around massive bodies. When we speak of how spinning objects distort space-time, we are touching one of the most poetic truths in physics. The idea that time is not a rigid ruler, but a river that can be stirred, twisted, drawn into whirls by the turning of stars and the churning of cosmic giants. Albert Einstein once reflected that time and space are modes by which we think, not conditions in which we live. And nowhere is that more evident than in the phenomenon we call frame dragging. Frame dragging emerges naturally from relativity, as if space itself were a gentle mist that a spinning mass must pull along, the way a spoon draws honey with it as it turns. This is not metaphor to a physicist, but measurable geometry. For decades, the idea remained elegant theory, waiting patiently for proof. until NASA launched Gravity Probe B, a spacecraft equipped with the most perfect gyroscopes humans had ever made. Francis Everett, the mission's principal investigator, said softly that the experiment aimed to see space-time itself move. And when the data finally arrived, it confirmed the prediction to exquisite precision. The Earth, turning once every sidereal day, was dragging the fabric of the universe by a minute but measurable angle, like a dancer gathering a trailing veil. Yet Earth is a gentle mover, a slow wheel compared to the furious turn of neutron stars. These collapsed remnants spin hundreds of times per second, so compact that a teaspoon of their matter would weigh more than a mountain. Their spin is not merely motion, but violence. Each rotation twists space-time with a force unimaginable on Earth, slowing clocks near their surface, curving paths of light, altering the very rhythm of reality. NASA's NICER instrument observed pulses from these stars and found space-time stretched and strained. The intervals between flashes altered not by mechanics, but by gravity and rotation entangling themselves in the heart of the cosmos. As physicist Janna Levin wrote, "A spinning star drags space into a swirl so powerful it can tear apart matter, fuse nuclei, and shake the universe with gravitational waves. If neutron stars twist time, then Kerr black holes reshape it entirely. Their spin is so intense that it creates an ergosphere, a region between the event horizon and the outer boundary, where space-time itself is dragged faster than any object can resist. Inside this zone, nothing can stay still, not even light. Everything must rotate, as if the universe forgot how to allow stillness. Kip Thorne once described it as the place where the flow of space becomes a whirlpool. And indeed, if you could drift near a Kerr black hole without being torn apart, your time would slow, your moments stretched like long threads pulled by unseen hands. What you called a minute might be an hour for the rest of the universe. Even our daily lives reveal the subtle pull of rotation on time. For the GPS constellation circling Earth, precision is everything. Yet those satellites live where Earth's rotation drags space-time differently, and their clocks tick at a slightly altered pace. Engineers must correct these tiny distortions constantly, or our maps would drift miles off course in a single day. Time dilation is not abstract. It is a quiet law underpinning every direction we follow. When light approaches a spinning black hole, its path bends into curves, spirals, even temporary orbits. Photons lose their straightness, dragged by a rotation they cannot escape. Observations from Chandra and the Post-Event Horizon Telescope show arcs of delayed light, echoes of photons forced to loop before breaking free. It is as though the black hole sings a deep, slow note, and light is compelled to dance to it. Astrophysics, in moments like these, becomes less a science of equations and more a poetry of observation. We watch time itself respond to motion, yielding to rotation like soft fabric, yielding to a twist. And as we contemplate these cosmic choreographies, we confront a strange intimacy, because the same laws ruling neutron stars and black holes rule the atoms within us. Even dark matter rotation, though silent, seems to obey this cosmic rule. Entire halos of invisible mass swirl around galaxies, shaping the curves of stars, anchoring structures we cannot see. And though dark matter does not shine, it participates in this universal dance of spin and gravity. A ghostly partner guiding the arcs of galaxies across billions of years. As a scientist, I find profound comfort in this unity. The idea that every turning thing, from the smallest particle to the largest galaxy, participates in a single woven truth, teaches us humility. Everything influences time, even gently. Everything leaves a trace. It reminds us that nothing moves alone, that motion is never isolated, that our universe is an orchestra where each rotation adds a note to the grand harmony of space-time. My personal reflection is this: if rotation can bend time, then perhaps every moment we live is shaped by unseen motions, not only in the sky, but within us. The fast spinning of neutron stars teaches us that even in collapse, motion persists. The swirl of a Kerr black hole reminds us that even darkness has structure. The frame dragging of Earth whispers that even everyday rotation matters. And GPS time corrections show that our world works only because we acknowledge the universe's subtle truths. The lesson I take is simple. Time is not only something we measure, but something we inhabit. Every spin reshapes it. Every mass bends it. And we, drifting on this turning world, are always part of that quiet reshaping. So take a slow breath, feel the soft rotation beneath your feet, and remember that even the stillness you sense is a kind of illusion. You are moving with Earth. Earth is moving with the sun. The sun is moving with the galaxy. And the galaxy is moving through a universe shaped by rotation and time intertwined. And in that layered motion, in that cosmic whisper, lies the most soothing truth of all. You are part of the universe's great turning, and time bends gently around you. In the quiet rhythm of the universe, every motion seems to hold a memory, a whisper from the beginning of time. When we speak of spin and its strange power over the flow of seconds, minutes, and years, we are really talking about the heartbeat of existence. The idea that a single quantum rotation inside an atom can define the length of 1 second may sound almost poetic, yet it is one of the most precise and profound truths of modern science. As Richard Feynman once murmured with a mixture of awe and resignation, nature uses only the longest threads to weave her patterns. So each small piece of her fabric reveals the organization of the entire tapestry. Inside an atomic clock, electrons shift between energy levels at frequencies so reliable that even the drift of a single photon becomes meaningful. The spin of those electrons is not a physical twirling, but an intrinsic quantum signature, a built-in piece of angular momentum that each particle carries like a name given at birth. When this spin flips, it creates a pulse. And that pulse is repeated billions of times each second, forming the foundation of the timekeeping that directs satellites, computers, and the rhythm of human civilization. Every moment we measure is anchored to the unchanging beat of electron transitions. steady and eternal, like a soft drum echoing in the void. Yet the definition of time in our world also rests on the motions of far grander scales. The rotation of the Earth around its axis and its long, graceful orbit around the Sun create the larger rhythms by which our species has navigated life for thousands of years. Day and night, seasons, shadows, and tides, all of them drawn from motion. These cycles feel natural because they cradle us, because we are born inside their flow. As Carl Sagan once reflected, we are like butterflies who flutter for a day and think it is forever, reminding us that our sense of time is inseparable from the spinning world beneath our feet. Still, the deeper question lingers like a star that refuses to fade. Who or what set the first spin into motion? What force touched the sun, the planets, the moons, and whispered, "Turn"? When our solar system formed from a collapsing cloud of gas and dust, gravity began its slow pull inward, and in doing so preserved every tiny bit of angular momentum that cloud once held. As it contracted, the rotation sped up, just as a figure skater spins faster when drawing her arms into her body. Nothing pushed the system to spin. Nothing commanded it. It simply honored a cosmic law older than stars. The conservation of angular momentum, a principle so delicate yet so absolute that the universe bends gently to keep it true. Angular momentum cannot be created or destroyed, only transferred, shared, or softened across time. This is why planets continue spinning long after the fires of their birth have cooled. Why stars rotate even as they age. Why galaxies swirl as if remembering their own formation. It is a choreography without a choreographer, a dance that sustains itself. Einstein hinted at this when he wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." He understood that time is not independent, not something separate from motion, but a shadow cast by the way space curves around spinning energy. Frame dragging, one of Einstein's most elegant predictions, tells us that rotation does not merely occur in space. It shapes space itself. When a planet turns, it gently drags the fabric of space-time around with it, like a spoon swirling through honey. The effect is almost imperceptible near Earth, but around a rapidly spinning black hole, it becomes a cosmic whirlpool. Light bends, time slows, and the flow of cause and effect begins to twist. This is the quiet magic behind the keyword frame-dragging Einstein, a key that unlocks how deeply rotation is woven into the architecture of reality. When we trace every thread of motion back to its origin, the universe does not reveal a prime mover. No divine hand giving the first push. Instead, it reveals balance, symmetry, and tiny cracks in that symmetry that allowed motion to emerge. Quantum fluctuations jittering in the newborn cosmos. Slight imbalances in density, heat, and charge. All amplified by inflation until rotation became an inevitable expression of the early universe. What we call spin today is simply the fossil memory of those ancient fluctuations, preserved across billions of years. It is tempting to think of the universe as intentional, as if it spun the planets because it wanted symmetry, or turned the stars because it needed rhythm. But the truth is quieter, and in many ways, more beautiful. Spin persists because nothing interferes with it, because friction is nearly absent in the vacuum of space, because motion loves continuation. There is no hand to guide it, yet it does not require one. The universe keeps moving because motion is the simplest possible state, a resting place for everything that once burned with creation. As a scientist, I find comfort in this simplicity, in the idea that the laws of physics are not commands but harmonies. They do not rule the universe. They accompany it. And the lesson I take from this is gentle but profound, that perhaps our own lives follow a similar path. We begin with motion inherited from everything that shaped us, from ancestors, dreams, memories. We continue spinning not because someone directs us, but because movement is natural to our being. And like planets, we carry the traces of all the collisions, blessings, and gravitational pulls that formed us. Every time I reflect on spin and time, I return to a thought once shared by Kip Thorne, one of the architects of modern gravitational theory. The universe is under no obligation to make sense to us. And yet, in moments like these, when spin guides the rhythm of seconds and space-time bends to the curve of motion, it feels as though the universe is whispering in a language we are just beginning to understand. Take a slow breath. Feel your own pulse, the rise and fall of your chest. Inside you, electrons still spin with the same ancient momentum that once turned the newborn stars. Your atoms still echo the first trembling motions of the early cosmos. And in that quiet realization, we discover that we too are part of the balance that keeps everything turning. Motion is not something we observe from the outside. It is something we carry, something we embody, something we remember. And maybe the true beauty lies in that gentle truth, that the universe doesn't need a hand to guide it, and neither do we. Motion persists, time unfolds, and we spin inside the same cosmic rhythm that began billions of years ago. In the quiet depths of cosmology, symmetry breaking is often described as the moment the universe chose to become interesting. It is the soft crack in a perfect mirror, the first tiny shiver on a still pond, the breath that turns silence into motion. Long before galaxies curled into spirals, and long before atoms dared to bind themselves into the seeds of life, there existed a state so uniform, so exquisitely balanced, that nothing had reason to move. Nothing had permission to change. Physicists sometimes call this the symmetry of the early cosmos, a state where forces were unified, particles interchangeable, energy evenly spread. And yet, as Stephen Hawking once said, the universe would be a very boring place if symmetry had remained perfect. Symmetry breaking, in its essence, is a moment of decision, not made by consciousness but by probability. It is the pencil standing on its tip, holding still for a miracle of balance, then finally tipping to one side, choosing a direction. When the universe cooled after the Big Bang rotation, the Great uniform fields that once filled all of existence settled into new values. And in doing so, they fractured the perfect symmetry that had held everything motionless. Nobel laureate Steven Weinberg wrote, "The world we know is the result of a broken symmetry." And perhaps those words have never been more true than in the first second of cosmic time. If the universe had stayed perfectly symmetrical, none of the forces we know would have emerged. Gravity would not stand apart. Light would not travel. Matter would not clump. And time itself would have no arrow. A perfect symmetry is a kind of eternal stillness. A balance so complete that nothing can change because nothing distinguishes one state from another. As physicist Sean Carroll beautifully said, "Time is what change looks like. And if symmetry is too perfect, there is no change. Therefore no time." So the cosmos broke its own balance. Not violently but gently, like ice cracking under the first thaw. Tiny fluctuations, quantum ripples blooming inside the primordial fireball, tilted the perfect symmetry ever so slightly. From those slight imperfections, energy condensed into particles, and those particles gained identities, stories, and destinies. Some would become quarks, some electrons, some photons, but all would inherit the same lesson. That difference is the mother of motion. This brings us to one of the most haunting mysteries in physics: the imbalance between matter and antimatter. According to every logical equation humanity possesses, the Big Bang should have created matter and antimatter in equal amounts. And yet, as we look around, everything we see, every star, every ocean, every breath, is made of matter. The antimatter is gone, erased in a cosmic flash where particles met their mirror twins and annihilated. But here is the miracle. There was just a little more matter than antimatter, a difference of 1 in a billion. This difference is what we call CP violation, a cosmic bias where the laws of physics ever so slightly prefer matter over antimatter. It is a tiny crack in the mirror of symmetry, but a crack large enough to allow everything we know to exist. As Andrei Sakharov suggested, our existence depends on the failure of symmetry. That thought alone is enough to make one pause, breathing slowly, as if the universe's earliest imbalance still hums somewhere inside our atoms. Then comes the Higgs field, the silent ocean of energy that permeates all of space. Before symmetry broke, particles had no mass, no resistance. They moved like light. But when the Higgs field settled into its lower state, like water freezing into a crystalline flow, it gave mass to particles, allowing them to slow, gather, and eventually form the building blocks of stars and life. Peter Higgs once said, "Without this field, there is no structure, only chaos." And perhaps he meant more than physics. Perhaps he meant that mass is the universe's way of giving things the ability to linger, to stay, to become real. As symmetry fractured at deeper levels, the forces split apart, gravity stepping away from electromagnetism, the strong force separating from the weak. Each division introduced more difference, more motion. The universe was learning how to change. And somewhere along this long unfolding tapestry, time discovered its direction. The arrow of time, often misunderstood, does not come from clocks or calendars. It comes from entropy, the gradual drift from order to disorder. But the universe could only drift because the perfect symmetry of its beginning had already been broken. Once differences existed, once gradients formed, once cold and hot, dense and thin, heavy and light appeared. Time gained a direction. As Richard Feynman said, the future is where the entropy is higher. And though the phrasing is mathematical, the meaning is deeply human. We walk forward because the universe itself walks forward. In this way, symmetry breaking is not just a physical event. It is a birth story. It is the moment the cosmos stepped out of perfection to become capable of creativity. Had symmetry remained unbroken, the universe would have stayed a silent ocean, smooth and endless. But because it fractured, stars ignited, elements formed, galaxies spun, and somewhere, much later, life learned to ask why. My own view, after years of studying these quiet revolutions of physics, is that imperfection may be the most sacred quality the universe possesses. It is the slight tilt that lets a raindrop fall, the faint imbalance that lets a heart beat, the whispered deviation that allows consciousness to shimmer awake. If symmetry had not broken, we would not be here to wonder about it. From this lesson, I take a simple truth: that the universe grows through its imperfections. And so perhaps do we. The next time you gaze upward, letting your thoughts drift like dust in starlight, remember that everything you see began with a tiny imbalance, a whisper of difference. And from that whisper, the cosmos learned to breathe, to move, to spin. And in that same breath, we return to the quiet mystery that threads through it all. If the universe began with a broken symmetry, what deeper turning waits behind the next veil of understanding? And what secret does that first imperfection still try to tell us? In the quiet drift of the cosmos, where galaxies unfold like vast spirals of silver fire, one question returns again and again, soft yet unsettling. Why do galaxies spin so fast without flying apart? And what unseen force holds their stars in place? When astronomers first traced the orbits of stars near the edges of spiral galaxies, they expected those distant stars to slow down, just as planets far from the sun move more slowly than those near it. But the universe whispered a different story. Stars at the outskirts were racing around the galactic core with nearly the same speed as stars near the center. By every classical law of gravity, that should have been impossible. The stars should have been flung into darkness, torn away by their own momentum. Yet they remained, orbiting faithfully, like beads threaded on an invisible string. Fritz Zwicky was the first to look into that darkness with suspicion. In 1933, while studying the Coma cluster, he realized the galaxies inside it were moving far too quickly for the visible mass to hold them together. He proposed the existence of Dunkel materia, dark matter, a silent weight woven through the cosmos. His idea was radical, and for decades the world ignored it. But the universe is patient, and truth has its own gravity. Nearly half a century later, Vera Rubin stepped into the night with a telescope and a simple question. Why do galaxies spin the way they do? Night after night, she measured rotation curves of spiral galaxies, and the evidence grew like a tide. Every curve was flat. Every galaxy whispered the same impossible truth. She concluded what Zwicky had once dared to guess. Something unseen was holding those stars together. Rubin would later say, "What you see in a galaxy is only the tip of the iceberg." A sentence that still echoes in observatories today. Dark matter does not shine, does not reflect, does not warm itself on starlight. It passes through us like a ghost, yet its gravity shapes everything. We know it exists not because we see it, but because of how it bends the paths of light and stars. Gravitational lensing became one of its clearest signatures. Light from distant galaxies stretches, curves, warps around massive clusters. In regions where there is no visible matter, the lensing remains, proving that something heavy occupies that empty space. As Einstein once said, gravity is not a force, but the shape of space-time itself. And dark matter carves that shape with a quiet but immense hand. The bullet cluster strengthened that truth. When two galaxy clusters collided, the visible gas lagged behind, slowed by friction. But the gravitational mass, mapped by lensing, raced ahead unhindered. It was the cleanest separation ever observed between visible matter and the true gravitational structure, proof that most of the universe's mass is invisible. Astrophysicist Sean Carroll once noted, "If you doubt dark matter, you're doubting gravity itself." Euclid now sweeps the sky, mapping the dark architecture of billions of galaxies. JWST peeks deeper, revealing that even the first galaxies, only a few 100 million years after the Big Bang, already rotated far too quickly to be held together by normal matter. Chandra captures X-ray ghosts drifting around clusters, showing us where visible matter ends and the true mass begins. Every instrument whispers the same answer. The universe is built on scaffolding we cannot see. And that scaffolding, the dark matter halo, surrounds every spiral galaxy like a quiet guardian. It stretches far beyond the luminous edge, extending like a vast unseen sphere. Without it, the delicate spiral arms would loosen, unraveling like smoke on the wind. But with it, the galaxy becomes whole, a cosmic wheel turning in the dark. Some scientists prefer to imagine that perhaps gravity behaves differently on galactic scales, that maybe the laws shift just slightly in the far reaches of space. But dark matter remains the simplest explanation, the one that matches observation after observation. As Neil deGrasse Tyson once said, "We are stardust within an invisible skeleton of the universe." When I reflect on this mystery, I feel a quiet humility rise inside me, a reminder that what we see is never the whole story. Galaxies teach us that the most powerful forces can be silent, unseen, patient. There is a lesson in that, a soft one. That sometimes the things holding our lives together are not the things we notice, but the invisible strengths we carry without realizing. As you listen, imagine those distant spirals turning slowly, each star gliding through a halo of quiet gravity. Imagine the darkness not as emptiness, but as structure, as foundation. And imagine that somewhere inside you, the same quiet forces might be shaping your own orbit. Even now, as JWST sends home its deep images, revealing galaxies from the dawn of time. The rotation curves remain flat. The mystery remains whole. The universe is still telling us, gently, that most of what exists is hidden. Yet the hidden is what gives everything its shape. Breathe slowly as you drift with this thought. Dark matter may forever remain unseen, but its presence is undeniable. And in its silence, it holds entire galaxies as effortlessly as a parent holds a sleeping child. This is the heart of the galaxy rotation mystery, a reminder that even in a universe full of light, it is the dark that gives structure, and the unseen that gives meaning. Beneath the quiet fabric of the cosmos, where starlight drifts like ancient breath, the question of whether the universe's own rotation shaped the twist of life itself becomes more than science. It becomes a meditation. When we look closely at the architecture of life, we find a beautiful imbalance. DNA spirals to the right. Amino acids curl to the left. A pairing so precise that even the smallest deviation would shatter the chemistry that keeps us alive. This asymmetry has puzzled scientists for decades, because nature usually prefers balance, symmetry, a kind of mirrored order. Yet life breaks that symmetry with quiet confidence, choosing one direction and discarding the other. As the Nobel laureate Frank Wilczek once said, "Nature breaks symmetry so that beauty can exist." But where did this preference come from? And why does every living organism follow the same spiraling rule? Some scientists believe the answer lies in the earliest starlight, back when the universe was young and raw, when massive newborn stars flooded surrounding clouds with polarized ultraviolet light. Light itself carries angular momentum, a sort of quantum spin embedded in the very wave. And when that spinning light strikes molecules, it doesn't treat both hands equally. In laboratory experiments at NASA's Ames Research Center, left-handed amino acid precursors were shown to survive UV bombardment slightly better under certain polarizations. A tiny bias. But in cosmic chemistry, tiny biases echo loudly. Carl Sagan once whispered a sentence that seems made for this moment. The universe is not required to be perfect. It is required to be interesting. Perhaps what we see in life's handedness is the universe choosing to be interesting, choosing a twist, choosing a direction. Then came the meteorite that deepened the mystery. In 1969, the Murchison meteorite fell gently into the fields of Australia, carrying with it amino acids older than Earth. And when scientists analyzed its chemical heart, they found an excess of left-handed amino acids. the same orientation used by life today. It was as though a small stone from the beginning of time whispered, "Life did not invent its direction. It inherited it." But the trail does not end there. It leads deeper, into the strange world of particles, where the fabric of reality itself chooses sides. Neutrinos, those ghostly particles passing through your body by the trillions each second, always spin left, never right. This phenomenon, known as parity violation, is one of the most profound discoveries in physics. As physicist T.D. Lee said after discovering it, the universe is biased, subtly, irrevocably, beautifully. If the basic particles of reality prefer one direction, then perhaps biology simply continued the pattern, echoing the spin of the universe in every cell. Astronomers have found clues in the largest structures as well. Galaxies across vast distances show a slight imbalance in their rotation directions, a whisper of a cosmic preference, a hint that the universe might have been born turning ever so slightly. This subtle bias, sometimes called the galaxy rotation mystery, may be the oldest fingerprint in existence, older than atoms, older than light, older than time's own memory. The astrophysicist Michael Longo summarized it softly. We are seeing the faint memory of the universe's birth spin, stitched into the galaxies themselves. And if galaxies can inherit their twist from the first breath of creation, why not life? Why not DNA? Why not amino acids? As I reflect on this tapestry of clues, from polarized ancient starlight to meteorites carrying asymmetric seeds, from neutrinos that refuse to spin right to galaxies that lean gently toward one direction, I find myself returning to a simple thought. Life is not separate from the universe. It is an expression of it, a continuation of patterns set long before the earth cooled or oceans formed. We are not choosing a direction. We are remembering one. In the quiet moments of contemplation, when the night is still and the mind drifts like a leaf on cosmic wind, this idea becomes almost tender, almost human. Every twist of DNA, every curl of a protein, every spiral in a seashell or hurricane, is a faint echo of the universe's first motion, carried forward across billions of years. We live inside that memory, shaped by it, breathing it, becoming it. And the lesson I draw from all this, after studying the stars, the particles, the stones that fall from the sky, is gentle but profound. Life is not an accident. It is alignment, a quiet harmony between the smallest motions and the largest, between quantum spin and galactic rotation. We are the thread connecting both. So when we ask, did the universe's spin decide the direction of life? We may already know the answer. Not because science has solved it fully, but because every molecule in our bodies already whispers it. Life curls in the direction the universe once turned, and still turns. And as you breathe softly now, listening to these thoughts unfold like starlight over water, remember that every part of you, every spiral of your being, carries a trace of the universe's first quiet decision. a decision written not in words, but in motion. Perhaps that is why the night sky feels familiar, why galaxies seem like distant relatives rather than strangers, because their spin and ours began in the same moment, the same breath, the same whisper of creation, and in that whisper, the story of life quietly turned into being. In the quiet stretches of cosmic time, when we step back far enough to watch the universe breathe, a gentle and haunting question emerges. Will the universe one day forget how to spin? This is not merely an astronomical curiosity, but a meditation on motion itself. For if everything we know was born from rotation, then the fading of that motion invites us to ask what remains when the turning slows. The first whisper of this fading lies here at home, on our gently spinning planet. Earth is losing a fraction of its rotation every century. A soft deceleration caused by the gravitational pull of the moon. The tides rise and fall. Oceans shift. And in that endless exchange of momentum, Earth's spin gradually ebbs. As NASA's geophysicist James Williams once noted, the Earth and Moon are locked in a slow dance of energy transfer, each step leaving a subtle trace in the length of our days. This is why our daylight grows longer by a few milliseconds each century, a reminder that even the rhythms we take for granted are not eternal. And as Earth slows, the Moon quietly drifts away, about 3.8 centimeters each year. It is a tiny distance, no wider than a fingertip. Yet on cosmic scales it is a loud message. The Moon's retreat is the natural consequence of tidal forces. For as Earth loses angular momentum, the Moon gains it, climbing slowly into a wider orbit. Carl Sagan once reflected, "The sky calls to us, and if we do not destroy ourselves, we will one day venture to the stars." But long before humanity rises to that challenge, our celestial companion will have drifted noticeably farther from our embrace. If this intimate story of Earth and Moon seems gentle, the cosmic version is far grander and far more profound. Stars slow down as their magnetic fields tug against stellar winds. Galaxies gradually lose rotational coherence as they interact, collide, and redistribute their angular momentum across vast halos of dark matter. It is a subtle reminder that rotation is not an infinite fountain, but a resource the cosmos spends slowly over billions of years. Astronomer Vera Rubin, whose work reshaped modern astrophysics, once said, "We are still learning how galaxies keep their shape, and how the invisible matter anchors their motion." Her insight touches the heart of the galaxy rotation mystery, a term that continues to challenge our understanding of how galaxies evolve, and more importantly, how they lose their spin. Without dark matter, galaxies would already have unraveled, their stars flung into the darkness like sparks from a dying fire. But with dark matter's gravitational grip, they hold together long enough for slow transformations to unfold. Over cosmic timescales, collisions smooth their spirals into spheres. Interactions dilute their rotational speed, and what once spun with youthful grace gradually drifts towards stillness. Yet nothing fades as quietly, or as poetically, as the spin of a black hole. Born from collapsing stars, they can rotate at nearly the speed of light, tearing space and time into luminous whirlpools. But even these titans cannot hold their spin forever, for Hawking radiation slowly bleeds their energy into the void. Stephen Hawking described it as the faint whisper of a dying star, the last breath of a curvature that once ruled its region of space. Over unimaginable epochs, even a rapidly spinning Kerr black hole loses its momentum, shedding rotation until all that remains is a final flash of energy. If black holes fade, if galaxies quiet, if stars slow and planets decelerate, then what awaits the universe at the farthest horizon of time? Cosmologists call it the heat death, a future where expansion stretches energy so thin that contrast disappears. Without gradients, without imbalance, without friction or force or tension, rotation loses its meaning. Motion may still exist in equations, but there will be no structures left to carry it. No galaxies to turn, no stars to sway, no planets to spin through their silent nights. The universe will become a vast, perfectly even sea of cold. Brian Greene once described this future as a universe where time itself loses its arrow, a place where nothing new can happen. And in that stillness, the loss of rotation mirrors the loss of narrative. For without change, there is no story. Yet even as we reflect on this distant and somber horizon, there is a strange comfort hidden within it. The fading of rotation is not a tragedy, but a reminder of the universe's long memory. Every turn, every orbit, every rotating particle has contributed to the grand evolution of cosmic structure. Without rotation, there would be no galaxies, no stars, no worlds where life could rise to wonder about its place. If the universe forgets how to spin, it will only be after it has spent billions of years creating beauty from motion. In my own view, the slow unwinding of the universe teaches us something quietly profound. Motion is precious because it is temporary. Rotation is meaningful because one day it will fade. Like the turning of seasons, or the beating of a heart, the rhythm of the cosmos reminds us that everything we love is shaped by change. When galaxies slow, when stars dim, when even black holes surrender their last rotation, the memory of motion remains written into the fabric of space. And just as the universe records its history through the fading of its spin, we too write our lives through the choices we make. So as we drift through this quiet reflection, let us hold one thought close. Rotation built everything we know, and its gradual fading is not an ending but a soft echo of the beginning. Even in the universe's final stillness, the memory of every turning star will linger. A whisper in the darkness, a reminder that motion once shaped the cosmos, and shaped us too. In the quiet hours when the mind softens and the world dims, there rises a thought as delicate as starlight. Perhaps we ourselves are the universe remembering how it once moved. Perhaps every heartbeat, every spark of awareness, every drifting thought is part of a much older motion. An echo born long before galaxies had shape. Angular momentum lives inside all matter, hidden not as a metaphor, but as a law. Every atom within us carries a whisper of ancient rotation. Its electrons moving through probability clouds shaped by quantum spin. Richard Feynman once said that nature uses only the longest threads to weave her patterns. And if we follow the thread of spin, we find it stretching from the earliest seconds after the Big Bang into every cell of our bodies. When we ask whether consciousness could be a memory of motion, we are not drifting into fantasy. We are stepping closer to physics, to the idea that thought itself is built upon electrical signals, signals born from moving charges guided by magnetic fields. What fires inside the brain is not stillness. It is motion, organized, rhythmic, persistent. Like a small version of the galaxy rotation mystery that governs the stars. Inside each neuron, ions drift from one side of a membrane to the other, producing a wave of charge. Those ions spin. Their electrons spin. Their magnetic moments interact. And from that endless dance comes what we call thought. Identity. The quiet awareness that looks out at the night sky and wonders. It becomes difficult not to imagine that our consciousness is built from motion, shaped by motion, sustained by motion. Carl Sagan once reflected that we are a way for the cosmos to know itself. And perhaps that knowing is only possible because the cosmos has never stopped moving. Even light carries spin. Photons twisting through the vacuum with angular momentum encoded into their polarization. When we observe the cosmic microwave background, that faint afterglow from 13.8 billion years ago, we are reading a diary written in rotations. Subtle patterns in the CMB, the curling B modes, the polarized swirls, are memories of how the early universe once shook, stirred, and spun. And when those photons enter the eye, strike the retina, and trigger electrical impulses, the universe's oldest motion becomes part of our newest thought. Everything we know about physics suggests that movement shapes time, perception, and reality. Einstein wrote that space and time are not conditions in which we live, but modes by which we think. And his theory of relativity shows how spin twists the very fabric of existence. Frame dragging, the slow swirling of space-time around a rotating body, is not poetry. It is measured truth. NASA's gravity probe B confirmed that even Earth, with its gentle 24-hour spin, pulls space-time into a soft whirl around itself. When we stand here, still, breathing, dreaming, we are already part of that curvature. We are wrapped inside motion so perfect and so smooth that we mistake it for stillness. If everything from galaxies to atoms is shaped by rotation, then consciousness cannot be fully separate from this great cosmic habit. Perhaps our thoughts are not isolated sparks of biology, but the smallest expressions of a universal tendency, the tendency to turn. This idea does not diminish science. It enriches it. It reminds us that understanding the universe is not only about equations, but about recognizing our place within them. Brian Greene once wrote that to be human is to be a collection of particles moving in patterns that allow awareness. A beautiful admission that consciousness is neither separate from matter nor superior to it. It is simply matter arranged in such a way that the universe can look back at itself There is a lesson hidden in all of this. A soft one. The kind that arrives slowly like dawn. When we feel small, or lost, or drifting through the world, it helps to remember that we are literally built from the movement of galaxies. The same laws that keep the stars in orbit keep the neurons firing inside our minds. The same angular momentum that shaped the Milky Way whispers through every atom in our bones. And as we follow that thread of motion deeper, something gentle becomes clear. The universe has never been still, and neither have we. Even in moments of silence, when life feels paused, we remain carried by motions older than memory. If consciousness is indeed the universe remembering itself, then perhaps our role is simpler than we imagine. To notice, to wonder, to let awe soften the edges of our days. Neil deGrasse Tyson often says that we are part of this universe. We are in this universe. But perhaps more important than both is that the universe is in us. And so the next time you look up at the night sky, feeling the quiet pull of something vast, remember this. You are built from spinning particles, shaped by spinning stars, living inside a spinning galaxy. Your thoughts are the latest ripple of emotion that began before time had meaning. You are not separate from the universe. You are a continuation of its first unforgettable turn. And in your quiet awareness, in your breath, in your soft curiosity, the universe remembers itself once more.